Anyone?
Is it the sheep foot roller and vibratory rollers?
Vibratory.
Smooth wheel, pneumatic tire rollers, rammers, and all those.
Not all of them.
Okay, so I will start by just going into a revision of those equipments. Okay, so because the thing is that it's this topic about the equipments is very important because it's generally asked in the examinations very frequently. Okay, it's very frequently asked like which which equipment is used for compacting which type of soil. So I will write it down. Okay, so there are some called rammers. Okay, it's for all soils. Can you see the screen? You can type Y. You can type Y.
Yes, sir.
Okay, so I'll write it down and you can copy it down. And I am parallelly recording this video also, and then I will be uploading it in YouTube. I am just recording it live because if you have any doubt, you can ask directly. So that's why I have thought of doing it. So this recorded video will be provided to you today itself in YouTube. So now rammers are used for all type of soils. Then there is called as one called as smooth wheel roller. Smooth wheeled rollers. It is used for generally crushed rocks, then gravels, sand. Okay. Then there is another called as pneumatic tired rollers. Pneumatic tired rollers. It is generally used for like both cohesionless and cohesive soil. Okay, so for cohesionless, we can take the example of gravel, sand, gravel, and also like cohesive soils are also compacted. So cohesive soils will be like silt, then clay soil. Okay, so uh, then sheep foot rollers are there. Sheep foot rollers. So sheep foot rollers is exclusively for cohesive soil, clay soil. Then there are at the end there are vibratory rollers, or we can uh, I'll write it just here. Vibratory rollers. It is used for cohesionless soils like sands. So I hope you can see the screen. So that's what I want to tell you. You have to memorize it. You have to just know like which uh, which equipment will compact what type of soil. Rammers, if it is given, all soil. Smooth wheel rollers will be for soil samples which are like a little bit bigger. Okay, crushed rocks, gravels. The pneumatic tire rollers are for both cohesionless and cohesive soil. Sheep foot rollers are for cohesive soil, that means clay soil, and vibratory rollers are used for compacting sense. So I hope I am clear with it. Any doubt, or can I proceed?
Yes, sir.
Okay, so I will proceed now. Let us talk about consolidation and compressibility. We have already discussed about compaction and consolidation. So consolidation is a long-term process, and compaction is the instantaneous process, as we have discussed. Now, uh, we already know that when we give a compaction to a soil, then there is a volume change. Okay, so there is a volume change when we give a force on a soil. Okay, and volume change happens due to what? Expulsion of pore water. This also we know, expulsion of water. We can say pore water, and also pore air. Okay, expulsion of pore air, air which is there in the voids. Okay, so what now we will discuss a term called compressibility. Compressibility. I want to ask you whether uh, like you have got this term compressibility previously. Have you got it previously? Compressibility, definition of compressibility, have you got? You can say N or Y in the chat box directly. Did you get this term previously? Compressibility, and what was the basically the definition? Compressibility is what? It is the amount of deformation per unit increase in stress. Okay, so compressibility is the amount of deformation per unit increase in stress. Amount of deformation per unit increase in stress. Okay, so uh, it depends basically on the permeability of the soil. Okay, it depends basically upon the permeability. So why it depends basically on the permeability? If the soil is less permeable, okay, if the soil is less permeable, then water will take much time to go out of the soil. Okay, just try to like understand it. If in a soil the permeability is very less, okay, then time taken by the water to move through the soil and go out of the soil is very much. Okay, permeability less means water will take more time. So when water will take more time to go out, that means uh, the soil will also take more time to get compressed. Have you understood this term, this concept? Type Y if you have understood. Type Y if you have understood. Like if permeability is low, then if permeability is low, then water will take more time to go out of the soil sample. So ultimately, the soil will take more time to get compressed. Okay, so that I can, you can just write one time, one line you can write, if k is very less, okay, if k is very small, this implies that time required will be very high. Time required will be very high. You can write it down. Okay, so that is the thing that you need to understand. Okay, now after that, when we talk about settlement, let's talk about settlement a little bit. Settlement means consolidation only in one. If you want to name it by another term, we can also say that consolidation is also settlement. Okay, so what are the three components of settlement? Do you know? Type yes or no. Do you know what are the three components of settlement of a soil? If no, then I will proceed. No problem. I will proceed with the discussion. So, all right, all right, all right. I will discuss with it. All right. So there are three components. You write down three components of total settlement. Number one is immediate settlement. Number two is primary consolidation. And number three is secondary consolidation. Please write it down. Type Y if you after you have completed writing. Okay. So, all right. Let me proceed. Now, what class do you have after this? Can you tell me? What class do you have at 11? What class do you have? Okay, 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 okay. All right. Um, so let me start with the first point, which is the immediate settlement. Okay. So I'll write it down. So I will remove the other two. So immediate settlement. So you see, it it occurs when the soil is fully saturated. Okay, it occurs when the soil is fully saturated. So it means that the soil should be like this. There is no air. Okay, generally soil was a three-phase system, isn't it? But in this case, there is no air. So the soil is fully saturated. So there are only soil solids and water in the sample. Okay, so now it's when you think about this soil sample, there are no gap for the air. Okay, when you think about this soil sample, there is no gap in the air. So if there is no gap, then the soil particles cannot move. And if the soil particles cannot move, then the soil particles will not be able to arrange themselves in a compact manner. Okay, did you get my point? Please type Y. If the air is not there, then there is no space to move, first of all. Then the particles, if you give a load, then the particles will not be able to arrange themselves in a compact manner. Okay, so then what will happen? Ultimately, there will be no volume change, first of all. There will be no volume change that you have to remember. So, did you get my point? If not, then I can repeat once more. No problem. I am looking forward to your responses. Okay, so all right. You see, now I will proceed. Uh, when the soil is fully saturated, I have told you the particles cannot like get settled. There is no space to like get settled, volume change. But what will happen? There will be some amount of distortion. Okay, um, some amount of distortion. Okay, and the soils will try to rearrange themselves. Okay, the soil will try to rearrange themselves, and if at all there is some amount of air, maybe here, like some amount of air is there, like this one, very negligible amount of air, very negligible, then that air will get expelled. So I hope I am clear, because anyway in a soil sample there will be some air present. Okay, there will be some air present in some way or the other, and if that air is there, it will get expelled. So then some negligible amount of volume change will happen. Okay, so if there is some air, air gets expelled, and some volume change will be there. Some volume change, obviously, because of the expulsion of air. But if we consider that the soil is fully saturated, okay, and no air is there, okay, then we cannot expect a volume change. Okay, in this case, we cannot expect a volume change. We can expect a volume change only if there is some air, and then air gets expelled and volume change will occur. Okay, so is it clear? Type C if it is clear this time. Type C. Okay, okay. So that is the thing. First part. This is the first part. Okay, okay, enough of C. Okay. So if it is the first part, if there is some air, air will get expelled and volume change will happen. If there is no air, then no volume change. Okay, and basically these things that I am talking, it is for the clay soil. This is for clay soil, or we can say cohesive soil. What I have told you right now, it is for cohesive soil. This, whatever I am telling you right now, is for cohesive soil. Now, if I look for cohesionless soil, if I look for cohesionless soil in the immediate settlement for cohesionless soil, then what will happen? This water and these solids, you apply a load P, and we are talking about coarse grained or cohesionless soil. Then as soon as you apply the load, all the water will go out. All the water will go out because water is not, this cohesionless soil cannot hold the water. Cohesionless soil, we are talking about cohesionless soil now. It cannot hold the water. Water cannot get stuck between this cohesionless soil. Okay, sandy, coarse grain, gravels, water cannot stay in between them. So as soon as you apply the load, water will directly go out. Okay, and volume change will happen. Volume change will happen. Uh, and this is logical. Okay, like here in cohesionless soils or coarse grain soils, the permeability is very high. It's very high. Water can easily go in and go out. Okay, but immediate settlement, when I discussed it for clay soil, okay, immediate settlement, first we discussed it for clay or cohesive soil, then the water gets stuck inside the soil particles. Water cannot move out easily because permeability is very less. That's why when I have told you that at the very instant water does not go out, so volume change will not happen. Okay, only if there is air, there will be some volume change. So one last time I am saying, in clay, water gets stuck between the particles. Okay, water gets stuck between the particles. So instantly, as you apply the load, water cannot go out. Only if there is some air, the water will go out and volume change will happen. Otherwise, no volume change, only if water and soil is there. Then we talked about immediate settlement for the cohesive soil. So in cohesive soil, water is not stuck in between soil particles. Water will move out instantly and volume change will happen. So type C, if you are clear. Okay. So now next one is the primary consolidation. Let us go to the primary consolidation. So primary consolidation means what? First, if we talk about clay, okay, if we talk about clay soil, today we will stop at primary consolidation. Okay. So for primary consolidation, if we look into clay soil, so if we look into suppose saturated clay soil, water and soil. So like saturated condition we are talking. So at the very the first one was what, immediate settlement. In the immediate settlement, when you just apply the load, it was like it was very early for water to go out. But after the immediate settlement has occurred, then some time will pass. Okay, and with time, water will slowly move out. Water will slowly, because even if it is cohesive soil, or you can say clay soil, water, it's not like water will be stuck there forever. Slowly water will move out. Okay, clay soil permeability is very less, so time taken will be very high. But even if the time taken is high, the water will anyway go out. So that is the second stage where water starts moving out. Okay, so this is totally due to primary consolidation is totally due to the expulsion of pore pore water. Okay, so and for cohesionless soil, cohesionless soil, in the first phase itself, in the immediate settlement only, like all the water moves out. It does not even reach the primary consolidation, because like instantly the water, if all the water goes out and there is no water left. Okay, but in clay, in the immediate settlement, all the water does not go out, and it takes some time. Then after some time it starts moving out, then it is primary consolidation. So for cohesionless soil we don't have much to write, because in cohesionless soil it is till now all the water has gone. Okay, it's all the water has gone. So in this part there is a concept of one area which we'll be discussing in details. It is called as effective stress. Now, for generally, if I tell you the formula, total stress is equal to effective stress plus pore water pressure. Please write down. We will go into depth of this formula. So write down. Total stress is equal to effective stress plus pore water pressure. Have you written type Y? Type Y after you have completed writing. Okay. So let me proceed. Let me proceed. So I will not go into details of it today. I'll just give you a brief idea of it. So whenever, if you take a soil sample, in the next class we will discuss it in the form of a formula. Okay, there is a like like definition in the form of a formula. We'll discuss it in the next class. But for today, I just need to give you the concept. So if there is a load, okay, then there are soil particles in the sample, and there is also water in the sample, isn't it? In the sample, there will be some water and there will be soil particles. So now, if the cross-sectional area we take it as A, okay, cross-sectional area we take it as A, then the stress will be what? Applied stress is P by A. Am I clear till now? Till now, am I clear? Someone can speak and reply. Anyone? Till now?
Yes, sir.
Okay. So this is the applied one. Now it has to be resisted by the sample. What are the uh, components of the soil sample that will resist? So this load will be resisted by. Will it be resisted by air? Because we can say that soil is a three-phase system: air, water, solids. Will it be resisted by air? No. So it will be resisted by the soil particles and also by the water. Okay, so the resistance given by water is called as the pore water pressure, and the resistance given by the soil particles is called as the effective stress. Are you clear with the basic idea? Basic idea? Are you clear? So
Yes, sir.
air will not give any resistance. Air cannot give. Soil will give and water will give. So whatever soil gives is the effective stress, and whatever water gives is the pore water pressure. So I will uh, I will go into details. I don't want to start this in-depth discussion now because it will be like half done. I want to start it and complete it at one stress. So tomorrow will be much better to discuss it. And then we will be ending with the third part, which is the secondary consolidation. We are right now in primary consolidation, and then we will be tomorrow we will discuss about this effective stress, and then we'll be ending with the secondary consolidation. So, all right then. Thank you for your patient listening, and thank you for your attendance. So we can end it here. I will send you the recorded video. I will upload it in YouTube today, and you can also like go through it again if you have any doubt. So with this, I am ending the class. Thank you.
Thank
Thank
you,
you, sir.
sir.
Thank you.